Okay, hello guys. So welcome back to another episode of my flipped classroom video. So again, this video is for flipped classroom purposes. So you have to watch the video before my class tomorrow so that you know how to do the activity in the class, because prior knowledge is what that you need to do activity in the class. Okay, now let's go on. So in this chapter, we're going to talk about pressure. Like I said, pressure. So you know pressure, but that is not the pressure that you feel. Like, for example, you have a lot of homeworks and then you feel pressure. No, we're not going to talk about that. We are going to talk something that happened in the real life. What is pressure? Okay, so this is still under the Newtonian mechanics. It means that this is the topics that related to things that happen around you. Okay, we are not yet going into electricity or electronics. Okay, but we are still in something that happened around you, and we're going to analyze why does it is important. Okay, so we go on. So in this chapter, you have 6 subtopics, which is pressure in liquid, atmospheric pressure, gas pressure, Pascal's principle, Archimedes principle, and Bernoulli's principle. In the last chapter, chapter 1, when we talk about force and motion, you have laws. But in here, in this chapter, you're going to learn about 3 principles. Now, this is very interesting principle because we are going to use the principle to build certain equipment or certain things, certain objects that apply these principles. It's very interesting. Okay, but before we go on the principles, you have to understand pressure in liquid, atmospheric pressure, and gas pressure. Now, when we talk about atmospheric pressure, actually you and me, as long as we are on the earth, actually we are actually under atmospheric pressure. Means that you will feel the atmospheric pressure, but you don't feel it. Why do I say so? Because you were born on earth. That's why you have biasa dengan atmospheric pressure. So that's the thing. Okay, then about pressure in the liquid, you have to understand how does the liquid cause pressure to this, and then what does the benefit if I know about pressure in liquid, and then how about the gas pressure? What is the benefits of knowing the gas pressure? Okay, so these are the things that you're going to know. So why is this chapter important? Okay, now for example, I'll just give you one example why it is important. Now, you know deep sea vehicles, right? For example, a submarine. So when we talk about submarine, we are going to talk about the buoyant force concept. So what is buoyant force? I'm going to explain buoyant force when we go to Archimedes principle. Okay. Now, so when it related to the buoyant force, it means that when the things is inside the water, means the things is experiencing the pressure in the liquid. So not only the pressure in the liquid, as long as you are on the earth, you are going to experience atmospheric pressure. So when the object is in the water, the object will be experiencing both atmospheric pressure and also water pressure. Okay, so when you are in an extreme depth, okay, we have to take into consideration about the atmospheric pressure and also the water pressure to make sure that we are safe when we are under the sea. So if let's say you do not take into consideration of the design and constructions of the vehicles, then you may risk your life. So that's the thing. So understanding the effect of water pressure at extreme depths enables the preparation for the expedition to the bottom of the sea and the constructions of equipment used, as well as precautions to be taken when working in high pressure environments. So actually, if let's say you look at the fish, right? You look fish around us. So different type of fish will live at different depth of the water. So sometimes their body adapt to the pressure. That's why they can stay alive in certain levels, certain depths of the sea. So that's the amazing thing about the life in the water. Okay, now to be honest, we still have a lot of type of fish that we haven't discovered yet, but the scientists is actually looking into it, and then there's still a lot of living creatures under the water, under the sea. Okay, because the water, actually the sea is very big, the ocean is very big, and then you have a lot to go on. All right, so that's the thing. So let's move on. Now, before I go on into the detail about pressure in liquid, I want to show you one short video.
お、すごい音。絶
対水すぐかかってるんですかね。
Okay, now let's move on. So today we are going to talk about pressure in liquid. So just now, the video that you watched is actually related to the dam. Okay, it's related to the dam. So you can see in this picture, this is an outlet of the dam, which is near to the base of the dam. So why does the water shoot out at a high speed? Okay, now first thing is I have to let you know this is the outlet of the dam, and then it is near to the base of the dam. It means that let's say this is your dam and then this is at the bottom. Why? So why is it that the water will shoot out at a high speed at the bottom of the dam? Now, actually, this concept is very logic. Now, I'm just going to give you one example. Let's say you have a plastic water bottle. Okay, plastic water bottle. You fill in the plastic water bottle with water. After that, you pop the hole, bottom, middle, and also the high part. So after you poke the three holes, you will see the water shoots out, right? Now, we will observe that the hole in the bottom, at the bottom of the water bottle, actually shoots the furthest. So that's why the depth is actually affecting the pressure. So that's the thing. Okay. Now, why is the outlet constructed near the base of the dam? Why? I think you have the answer now because I just gave you one situation with the plastic water bottle just now. So what are the factors affecting the water pressure? Now, this is the question I'm going to ask in the class. What are the factors affecting the water pressure? After you finish watching this video, I believe you know what are the factors affecting the water pressure. Now, let's move on. So very first thing here is you have to know how to derive the formula. So you know that, okay, now in the topic that I given here is to derive the formula P is equal to H rho G from P is equal to F over A and rho is equal to M over V. Now you learn about pressure when you're in Form 2. You learn about pressure when you're in Form 2. I'm going to ask the question related to the Form 2 topics about pressure. Okay, I'm going to ask in the class. I'm not going to share here because today's video takes a long time because it's quite a lot of slides and I have to explain one by one. So I'm not going to explain detail about P is equal to F over A. I'm going to ask in class. Okay, now let's focus here. So let's say, okay, I have these diagrams here. Then this diagram consists of liquid with density P. The purple color is liquid. And then the blue color is the liquid column, means that actually another cuboid is actually put inside the big cuboid. Okay, so that's a thing. So this is the big column, the liquid column, and then this is the liquid of the density. It means that this is the different space here. Okay, now let's see here. So to find the volume of the liquid column, now this is the liquid column, the blue color one. I know that to find the volume. How to find volume? Volume is actually the area, the base area multiplied with the height. Again, I repeat, the base area multiplied with the height. I know V is equal to AH. So that's the first thing. Next one, to find the mass of the liquid of the column, I know that M is equal to V times density. Now, where do I get it? Now, this is what we have. Density is equal to mass over volume. Density is equal to mass over volume. That's why when I move, I want to find mass, right? When I move the volume to the other side, I have volume multiplied with density, which is volume rho. Volume rho. Okay, this is what I have here. Then move on. So I know that this is how I derive from rho is equal to M over V. Next one. Weight is equal to mass times gravitational acceleration. How do I get this? Weight is equal to mass times gravitational acceleration. So do you remember that, right? Okay, so W is equal to mg. Next one, to find a pressure. How to find a pressure? This is the definition I have. Pressure is equal to force per unit area. This is what you learned when you were in Form 2. P is equal to F over A. F is also equal to the weight. F is also equal to the weight. So I replace the F with weight of the column divided by the surface area. What is the surface area? The surface area here. Okay, so I know that pressure at the base of the liquid column, this part, this is the pressure, and then it's equal to W over A, which is also equal to F over A. Next, I'll get, after I substitute mg inside the W, I get P, pressure, is equal to mg over A. Then I replace my mass with V rho. So after I replace V rho, and then I get V rho G over A. Okay, it's still not finished yet. Okay, what do I have here? I know that my volume is equals to A multiplied with H. So I replace my volume with AH. So I get AH rho G over A. Then I can cancel out the A. I get P is equal to H rho G. Now, this is how I derive the formula P is equal to H rho G. You have to know how to derive the formula P is equal to H rho G because this is one of the learning outcomes that you have to know. Okay, your learning experience is totally different from the KBSM last time. KBSM student, they just need to know P is equal to H rho G and how they use it. But your learning experience, you need to know how to derive the formula. Okay, so you may rewatch it or you may try this. Okay, let's say you don't understand, I'm going to explain in class. Okay, now let's move on. So I know that P is equal to H rho G. So where P is the liquid pressure, H is the depth of the liquid, rho is equal to density of the liquid, and G is the gravitational acceleration. So the SI unit for pressure is Pascal, or 1 Pascal is equals to 1 Newton per meter square. Now, how do I get this? How do I get Newton per meter square? This is where you get it. P is equal to F over A. You learn this one in Form 2. Now, let's say you don't remember about this. You ask me in class. So I'm going to explain to you. Okay? Or 1 kg per meter per second per second. Okay? So this is what I have. Then, what are the factors affecting the liquid pressure? You know from the formula P is equal to H rho G, right? So actually, it's very easy. What are the things that are affecting the liquid pressure? Now, we know that as long as we are on the earth, then our gravity acceleration will always be the same. So that's why G is constant. So the thing that is going to affect the pressure is H and rho. H and rho. So what is H? H is the depth of the liquid. So when the H is high, when your H is high, you will have a higher pressure. When your H is low, then you have a lower pressure. Okay, so about density, same. If let's say I have a things with a higher density, then I have a high pressure. If the things I have a low density, then I have a lower pressure. Okay, this is what I have. Now you will have an experiment, okay, related to this, related to the factors affecting the liquid pressure. Now, first thing now, please remember, what are the factors affecting it? After you understand this, and then we're going to try on the experiment, you're going to compare whether the theory is actually fulfill your practical experiment. Okay, so let's move on. Now, there's another very interesting facts here. Now, if let's say you were given this type of tools or equipment, okay, or what did I say? That these types of columns, okay, then you fill in water into it, then you find out that actually the height of the water are the same. The height of the water levels in these different columns are all the same. Okay, this means that cross-sectional area and the shape of the column do not affect pressure in liquids. Okay, so this is the factors. Okay, please remember, the cross-sectional area and also the column, the shape of the column, whatever the shape of the column will not affect the pressure in liquid. Okay, now, so that's the thing. All right, now, another one. Water spurts out of all three holes at the same level. The plastic bottle has the same horizontal spurt distance. Okay, now what do I have here? Now let's see, this is the water bottle. Okay, just now, the first example that I show you just now, that I mentioned, it's not I show you, I mentioned. You have a plastic water bottle and then after you poke 3 holes with different level. Right now, let's say if I have a plastic bottle filled with water and I poke the 3 holes at the same level. So what happened here is all the 3 holes will have the same horizontal spurt distance. So it means that when the water spurt out, their distance are the same. So this is what you observe. Pressure at a point in liquid acts in all directions, and points at the same level have the same pressure. Now, this is the things that you have to remember. Pressure at a point in a liquid acts in all directions. Points at the same level have the same pressure. So that is the thing. Now, these points at the same level is a static liquid have the same pressure. Now, what do I mean by static liquid? Static liquid is like this. Now, let me just show you the previous diagram. Okay, now, this is what I mean by static. It means that the water cannot flow out from here. It cannot flow out from E and then it cannot flow in from A. So what do I mean by non-static water? Means that the water is keep on filling in at A and then coming out from E. So that time you will have a different levels. The height of the water levels will be different. So that is what we are going to discuss in the next topic, not today. Okay, so for today, you just need to focus on static water. So when the water is in static, that's why the water will have the same pressure. Okay, the water will have the same pressure. Now move on. Okay, now another interesting things that you have to know about this is the YouTube. This is a tube that we call YouTube, not the YouTube that you watch in video. No, this is the YouTube, or we call it manometer. Now this YouTube is filled with liquid X. Then we add the liquid Y, okay, on the other side, this this side. Okay, so we put it in, then these two liquid must not mix up. Okay, so we put it in, so you see that the water is being separated. So means that liquid Y and liquid liquid Y and liquid X will have different density. So this apparatus can be used to compare the densities of two immiscible liquid. Okay, two immiscible liquid. So we are going to compare the liquid. Okay, now amazingly, okay, when you look at this diagram, amazingly, the pressure are the same. Okay, the pressure are the same. Now let's analyze one by one. So initially, I have liquid pressure at point A. This is point A. This is my point B. Remember, right? In the previous diagram, previous slide. Okay, let me just show you this slide. It shows that as long as you are at the same level, your pressure are the same. So now we're going to take into consideration the point A and B. They are at the same level. So that's why point A, how do I get point A is P1 is equal to H1 rho 1G, where rho 1 is density of the liquid X. Okay, next one. For P2 is equal to H2 rho 2G, where rho 2 is equal to density of the liquid Y. So what happened here? Since points A and B are at the same level and both liquids are static, then pressure at point A is equal to pressure at point B. So what I'm going to do, I'm going to just put the formula inside. So when I put a formula inside, H1 rho 1 G is equal to H2 rho 2 G. Now, as I mentioned this now, because our gravity is constant, I can cancel out my G, then I get H1 rho 1 is equal to H2 rho 2. So the value of H1 and H2 can be measured by using a meter rule. So let's say if this experiment or this activity you're conducting in class with manometer, then you can measure the height. Okay, you can measure the height by understanding, by knowing the height, both height, then you can find out the density of liquid Y. Now let's say liquid X is water. Liquid X is water. Then what is the density of liquid Y? Now, as long as you know what is the density of the liquid Y, you can predict what type of the liquid that we used to put inside there. So that's the thing. Okay, so let's move on. So we are going to look into the applications of pressure in liquids in our daily life. So what are the things that you see? Actually, you saw this in your daily life. Maybe you just don't realize that it actually related to physics concept. Now, for example, the positions of the water tank in the house. Now, you see this King Kong, right? King Kong tank. So the water tank is normally placed in the space between the ceiling and the rooftop. Okay, why? Because the difference in height between the water level in the tank and the water tap produces a high water pressure at the tap. I repeat this. The difference in height between the water level in the tank and the water tap produces high water pressure at the tap. So water flows at a high speed when the tap is turned on. That's why you will realize that for the people who stay in condominium, okay, sometimes they will have problem with the water. Sometimes they will have problem with the water pressure. Okay, so especially for the people who stay at a high building, at the high level. Okay, but normally they don't need to worry because they normally will put that tank and at the rooftop. Okay, at the rooftop. So this is very interesting. And then another one. This is a position of intravenous liquid. Now, this is also important. You need to know this. If let's say you want to become a doctor, that's the thing. This is the thing. You want to become a doctor, you cannot run away from physics because there are a lot of things that related to physics in medication. Okay, if let's say you don't know, you want to be the doctor to give the MA that give medicine, that's a different story. Okay, then but the physics concept behind the medical you need to know. Say for example this one. The bag of the intravenous liquid is placed at a position higher than the body of the patient. Why? The pressure due to the difference in height of the liquid columns push the intravenous liquid into the body of the patient. The rate of flow of intravenous liquid into the patient's body depends on the height of the bag, can be controlled by the adjuster. So you see this nurse is actually holding the adjuster. So that's why that it will control the drop, okay, the drop into the patient's body. So if you realize it when you donate blood, where is the position of that bag? Try to observe it. If let's say you are donating blood, will be the blood bag, okay, on top, or should it be under your bed? So you try to observe this. This is very interesting. Now, next one, the construction of the dam. Now, in Malaysia, we have a lot of rivers, right? We have a lot of rivers, and our generator basically is using hydro generator, especially in Sarawak. Okay, especially in Sarawak, we have a few dams there. Okay, so the wall of the dam is built thicker at the base of the dam because the water pressure increases with the depth. So you see here, this is the hydroelectric dam. So this part is actually thicker compared to the upper part. Why? The thicker sections of the dam is able to withstand the high water pressure. The penstock is at the lower section, that this is the penstock, lower section, so that the high pressure, water pressure will produce a fast flow of water to drive the turbines. So when the turbine is being driven, then it will generate the power. Okay, it will generate electricity. Now, this is a very interesting thing. You're going to learn about how the generations of electricity when we are into the electricity topic. Okay, so I'm not going to talk further about that, but like I said, physics is linked. Today, we are talking about the construction of dam, how the hydroelectric dam produce energy, produce energy, kinetic energy into electricity energy. And inside the electric topic, we are going to see how does the electricity works. Okay, this is very interesting. Now, move on. So this is another one, the use of siphon. Okay, a siphon is used to transfer water from a higher region to a lower region. One end of the tube is filled with water, is placed in the tank of water at a higher position, while the other end is placed at the lower position. Okay, you can see here. So this is at a higher position and this is at a lower position. The flow of water from ND produces a region of lower pressure at point B. I repeat, the flow of water from ND produces a region of lower pressure at point B. Atmospheric pressure pushes water into tube A. Okay, so the atmospheric pressure here will pushes the water downwards, and then the water is going to push it into the bin. Okay, now guys, so after you understand about the concept behind the siphon, so what I'm going to do is in the class tomorrow, we're going to try an activity about a simple siphon consists of flexible tube, and then the liquid actually can transfer out continuously from a simple reservoir for a period of time without the use of electrical power. So what are the factors that affect the rate of transfer of liquid using siphon? Okay, now I'm going to do this activity in groups, so you are going to discuss. There will be a worksheet, and then you're going to try. I'm going to try. We are going to discuss about this. All right. So basically, this video is about what I have now. So see you in the next class. Thank you. Bye.